All right. Let's go in blind on a daily. Sorry, I missed this yesterday. I was a little bit busy. 1460. Make two arrays equal by reversing subarrays. Interesting. You're given two integers arrays of equal length, target and array. And R. In one step, you can select any non-empty subarray of R and reverse it. You are allowed to make any number of steps. Return true if you can make R equal to target, or false otherwise. Interesting. So we need to find a way that we can check to see if we can flip Oh, wait. Sorry, I thought that it was just for one reverse subarray, but you can reverse plenty. Well, if that's the case, you just have to check that all the values are equal, right? Is that right? Okay, I mean, if they can be equal, that means that they just share all the same values. So let's just say for value in target, if not value in R, return false. And then otherwise, we just check to see if they are the same length. Okay. Does that work quickly? Wrong answer. Oh. What? Really? Well, I guess we do need to worry about if there's two of the same value. Okay, so we'll use this test case. So I was right in my assumption of just checking for array equality in turn, like basically just that the two arrays are the same length and are just mixed up. You would be able to reverse any, well, subarrays and eventually reach the right point, right? You know, you just like swap them enough. There's no limit to how many times you can swap them. So how do we worry about that one case? Well, I don't want to use delete. Because delete would take a while, right? Now let's use remove. I don't know. I don't care. I'll remove it, and then, because this way, if there's two of the same value, well, if there's two of the value, because right now the problem is that there's two twos in target, but there's 1 2 in array. So when I check this one, it compares it to this one. Then when I check this one, it compares it to the same one. So even though they don't match, it thinks that they do. So this will take a while, but I don't care. It's a pretty straightforward problem. Wrong answer. Really? How? Oh, yeah, because at the end I checked the length. So now let's just put this at the start. Because I was comparing the lengths of the two arrays. Because if they ever differ, then you know that they can't be the same. So then now if you get to this point, return true. And I feel good. I think I'm just going to submit this. Okay, awesome. Very slow, but I don't care. Yeah. Yeah, so I just compare the length. And then after that, I compare. Okay, maybe there's a faster way that we can do this. Hmm. Oh, that makes sense. Yeah, this is a lot better. So this is just almost making a sort of dictionary, and it counts the number of appearances of every number and uses their number as basically the index. That makes a lot more sense. Why don't we just implement that right now? I'm gonna still keep this because this will weed out a lot of ones. Otherwise, we get to. We're gonna make a dictionary called appearances. And we're gonna say, okay, so for value in target, why don't we say target counts and R counts. For value in target, we'll say, so we'll check to see if it's in there. Okay. If value in target counts, add 1 to that count. Otherwise, set it to 1. Because it has 1 appearance. And then we do the same thing for R. And then we can just say return target counts. Do we have to use no. Equals R counts? Can you do equality like that? I mean, they would be the same, right? I don't know. Let's see. Cool. Does that work faster? Okay, slightly faster. Pretty good on memory. I wonder what happens if we submit it again. Will we get faster? Yeah, okay. So that's about as good as you can do, considering how much it jumped just based on running it 2 different times. So, sorry, I wasn't as vocal on this one. Just because, yeah, I'm getting back into it. It's been a couple days. So first thing I do is, so the first thing you gotta do is just break down the problem. I'm basically saying, okay, so if you can just do infinite swaps, then as long as they have all the same values, then you can return true. Otherwise, if there's any differences, return false. So this seems complicated, but I'm actually glad that I did the other option because you see why it took so long. Because the intuitive way to do it would be to iterate through one array and see if it appears in the other array, but that doesn't consider what happens if there's multiple values of the same, well, multiple of the same values in either array. Then you might get thrown off because target, like basically 1 3 could equate to 3 3s in the target array. So the values, you'll get what seems like equality, but you won't. So then what I did was I started removing the values, but removing takes forever in an array because if you have like 1 2 3 4 and you say remove 1, you think of it as just, okay, well, I'm deleting 1 value, but deep down what's actually happening is that means that the 2 has to go to the 1 and the 0 index, the 3 has to go to the 2 index, and the 4 has to go to the 3 index, or the 2 index. So that's why that takes forever, because it has to do that for every single time it removes a value. It's shifting over every single one of these values. But yeah, there we go. Done. That was a fun one.